continue on with chapter 2.1 and sets. Let's go ahead and start with this problem here. Now that we have some idea of Venn diagrams and sets, we have a better idea of how to answer this question here. There are 30 elementary school teachers, which high school courses they appreciated. We have algebra and geometry. 17 appreciated algebra, 15 geometry. Of these, 5 said they appreciated it both. So of these over here, of the 17 and 15. And so what I now know is that this number here, the one that had both, would be 5. And out of these, 15 said geometry altogether, but this would leave me 10. Because out of the 5 of these here, so like both, that leaves me 10 left over. Out of the 17, that leaves me 12 left over. And so how many appreciated neither? This is going to be the group outside. How many are outside of these circles? And so we know we had 30 total. And so I have 12 plus 5 plus 10. And so I'm looking for how many to make my 30. So that's 17, that's 27. And so the amount that's left out is 3. There are 3 teachers who appreciated neither of those. And so again, that's looking at this idea of sets, intersections, unions. 27 altogether. 3 are on the outside there. That leads us to this outside is an important concept. If you're outside the group, right? And so in this case, we would call that the complement of A. The complement of a set, written A with A bar on top, is the set of elements in the universe that are not in A. So everything outside of A is the complement. And so I've done some examples here for us already. You can see the complement of A. If A is A, universe is A, B, C, and D, then this is the complement. This is everything in U, but not in A. And then we have the same thing here with B and C. This is everything. The odd numbers are everything not in B is all the even numbers. This is all the odd numbers are left over. That's the complement of even numbers is the odd numbers. That last one's a little bit harder. Take a look at that. So looking at this last example, it's definitely more complicated. I put out the complements of each of these first, the complement of A and B, and then you do the union of A and B, and you can see what you get here. You get the 1, 2, 4, and 5 when you put those together. On the next one, the intersection of A and B, I did that first, which just turns out to be 3. And so then the complement of the intersection, right, is everything not in the intersection. So that's 1, 2, 4, 5. There's 2 more operations, one called the difference between 2 sets, or what's called the relative complement, but I like the difference because of the subtract. So that's basically all the elements in A that are not in B. And so you can see the answers for those here. You're basically taking out take out B, right? Look at A and then take anything out that comes from B. And so that's just A and C. Here, it was just A, B, and C because there's nothing from B in A. Here, B, C, and D are in A, so all that's left over is A. That's the difference between them. And then the last piece is Cartesian product sets. We're not going to use this very often, but it was just, again, worth mentioning because we use this in multiplication, and we do this in when we graph and we make ordered pairs. But there's another operation called A cross B. That's how you would say that. And then you end up with a set of ordered pairs. You match up each element from each set together as a pair. And so that's your Cartesian product, or A cross B.